Okay, this is Looking Ahead, Section 1, Polynomials. A polynomial is an algebraic expression that contains one or more monomials. And if you recall, a monomial we saw in Lesson 9.2, it's a number, a variable, or a product of numbers and or variables. So monomials cannot contain any addition or subtraction. But a polynomial can contain one or more monomials, so it would have addition or subtraction, or it could. It wouldn't have to, but it could. Recall that like terms are terms that contain the same variable. Like terms must also contain the same exponent. So for example, x squared and x are not like terms because they do not have the same exponent. When writing polynomials, we usually write them in standard form, meaning that the powers of the variable are written in decreasing order, so from biggest to smallest. And your textbook relies very heavily on algebra tiles to model polynomials. We are not really going to take that approach, but it is somewhat helpful if you get a little confused from time to time. Sometimes those pictures can help make things a little bit clearer, but your notes will not reflect anything with algebra tiles, and what we do in class won't really reflect that either. But if you want to see the examples in your textbook to see how that would work, you're free to do that. Okay, so if I want to simplify a polynomial, like in example 1, really all we're doing is combining like terms right now. So I look at this polynomial and I see, and remember we want everything in decreasing powers of the variable. So I see that the highest power on x is just a power of 1. So that would be the first thing I would look for. So I have a negative x here and a negative 2x there. And remember, when we combine like terms, we keep the variable and whatever exponent it has the same. We're just adding the coefficients. So this is a negative 1 and a negative 2. When I add those, I get negative 3x. And then I have some numbers that are also like terms, a plus 1 and a plus 5. And of course, when we add those, that's plus 6. Okay, for this one, the highest power on x that I see is 2. So we would start with that so that we have everything in decreasing powers. So here's an x squared, and here's another x squared. So that gives us 2x squared. Remember, the exponent does not change when you're adding like terms. You're just adding the coefficients. So 1x squared plus 1x squared is 2x squared. The next one we see is this plus 3x, and there's nothing else that goes with it, so we'll just bring that down, and then plus 4. Okay, one more. So again, here we look for the highest power on x, and I see a negative 2x squared here to go with a plus x squared there. So negative 2 plus 1 is negative 1, or just negative x squared. And then we also have these two numbers, plus 5 and minus 1. And when we add those, we get plus 4. Okay, so for the try it yourself problems, you're going to do the same thing. Simplify each polynomial. Make sure that your answers are written in decreasing order of the powers. Um, so pause the video, work through those 3 problems. When you're ready to check your answer, press play. Okay, this first one is 5x squared plus 7x minus 2. B is negative x squared plus 2. And C is x squared plus 6. Okay, we can also use polynomials to write expressions to represent the perimeter of a figure. So here we see a figure where we know that these two sides are 6 feet long, but these have variables involved, 3b feet, whatever b is, and 5b feet. So if I want a polynomial expression for the perimeter of the figure, of course for perimeter we know that we just add all 4 sides. So we have 3b plus 6 plus 5b plus 6. So just adding all 4 sides. Well, from here we can combine like terms. So the highest power I see on the variable is just a power of 1 in this 3b and the plus 5b. So then 3b plus 5b is 8b. And then we also have a plus 6 and another plus 6, which is plus 12. So that is an expression, a simplified polynomial expression for the perimeter of this figure. All right, so for the try it yourself problem, you're going to do the same sort of thing. So pause the video and answer that question and press play when you're ready to check your answer. Okay, here for the perimeter, you should get 18x plus 6. And really, this should be written with parentheses followed by the units. So we should actually have that on the previous example too. So this should be um, in parentheses with feet as our units. All the parentheses do here is group this together, so it's not saying it's 8b plus 12 feet. It's actually 8b plus 12 feet. So that's what that's for, just to group those together so they all together represent the perimeter and um, not just the last part of it being in feet. Okay, so that is pretty much it for section looking ahead 1. It's just an introduction to polynomials, basically. So we're going to go to looking ahead 2, where we are adding polynomials. And this is going to look fairly similar to what we did with simplifying in the previous section. So to add two polynomials, all we're doing is combining like terms. So there are a couple ways to set this up. So we have enough examples. I'll show you both ways to do this. Sometimes it's easier with adding, especially when we get to subtraction in looking ahead 3. Sometimes it's easier to arrange like terms in columns and then add them that way. So I'll show you both ways and you can use whichever one you'd like. Okay, so here we are adding this polynomial, x squared plus x minus 3, and we're adding to that 3x squared minus 4. Well, if you think about this, these parentheses here, yes, they group this polynomial and this polynomial, but really, because it's all addition, these parentheses are not necessary. So really what we're doing is just combining like terms still. So again, we'll look for the highest power on x, and I see an x squared. So we're going to combine x squared with 3x squared, and that would give us 4x squared. And then the next highest power is just this x all by itself, so plus x. And then we still have a minus 3 and a minus 4, which is minus 7. Now if you wanted to arrange these in columns, you'd start with the first one, x squared plus x minus 3. And then we want to add to that 3x squared. So we'd put the 3x squared underneath the x squared since they're like terms. And then the minus 4 underneath the minus 3. So now when we add, we can just add straight down. 1 and 3 is 4x squared. There's nothing to add to this, so we just bring it down. And then negative 3 and negative 4 is negative 7. Notice you get the same answer, it's just a different way to approach it. And again, when we get to subtraction, this method might actually be easier. So I would say be sure that you can use either one, because you may want to switch to this when we go to subtraction. Okay. So here, and this time let's do the columns method. So here we have negative 2x squared minus x plus 1. And we want to add to that negative x squared. So we'll line that up here so that we have like terms together. And minus 3x, so that'll go underneath this minus x. Okay. So now we just add straight down. Negative 2 and negative 1 is negative 3. And we'll keep the x squared the same. Negative 1 and negative 3 is negative 4x, and then bring down the plus 1. Okay. And one more. So this time we'll just combine like terms so that you've seen both ways to do this and you can choose which one you prefer. So here, when we combine like terms, we have the biggest power is x squared, and we can add to it a negative 2x squared. So 1 and negative 2 is negative 1x squared, or just negative x squared. We have a minus 4x and a plus 5x. So when we add those, negative 4 plus 5 is 1. So that would be 1x, or just x. And then a minus 1 and a minus 3. And negative 1 and minus 3 is negative 4. So negative x squared plus x minus 4. Okay, so there's a few for you to try on your own. So pause the video, and you can use, again, either method. You can just combine like terms, or if you want to line them up in columns and then add, that's fine too. So pause the video, work through those 4 problems, and when you're ready to check your answers, press play. Okay, for the first one, for A, you should get 6x plus 10. For B, 3x squared minus 3x plus 4. For C, just 6x. And for D, negative 2x squared plus 2x plus 3. Okay, last page. Okay, so in the previous section, we wrote some expressions to represent the perimeter of figures. So we're going to continue that a little bit further in this section. So this says a rectangle has a length of 4.6x units and a width of x units. Find a formula for the perimeter of the rectangle. Well, we know that the perimeter of a rectangle is just adding all 4 sides. So we have 2 lengths plus 2 widths. So the length is 4.6x and the width is just x. Okay. So here we just have all like terms to combine. So 4.6 plus 4.6 plus 1 plus 1. When we add all those together, we should end up with 11.4. X. 4.6 plus 4.6 plus 1 plus 1 is 11.4. So this is a formula for the perimeter of this rectangle for whatever value x takes. Now part B asks us to find the perimeter of the rectangle if its width is 3.2 meters. So width, we go back to the original problem, the width was x. So this is telling us that x is 3.2 meters. So we'll take the simplified formula that we have, P equals 11.4x, and we'll replace x with 3.2. 11.4 times 3.2. We end up with a perimeter of 36.48 meters. Okay, so there's some try it yourself problems that are very similar. So go ahead and pause the video, work through those 2 problems, and when you're ready to check your answers, press play. Okay, the simplified formula for the perimeter of this rectangle should have been P equals 6x squared minus 8x. And then when you substitute 5.4 for x in part B, you should end up with a perimeter of 131.76 units. And I think oh no, we did put units on that last one. I thought maybe we had forgotten them. Okay, so that's it for adding polynomials. Next time we'll look at subtracting polynomials, and we'll do a little bit of multiplication also.